Thank you so much for waiting, guys. So let me share my screen now. Okay, so let me open the presentation. So in our last session, we have understood all the things related to cloud computing, right? We have seen the introduction to cloud computing, and we have seen advantages of cloud computing and features of cloud computing. Everything we have seen in our last session. So today we will try to understand how actually the data engineering got evolved, and where are we at in terms of engineering, right? So to understand that, I want you to begin with the traditional systems where we used to use these RDBMS systems as the data warehouse systems. So first, before going to cloud data engineering, especially to GCP, I want you to understand how this data engineering got evolved in the past, right? So that is something that you need to understand. What are the technologies that were there in the past, and how the technology evolution is happening, and what are the technologies now to learn to become as a data engineer, right? So these things I will try to address today. And in that process, I want you to introduce one of the technology called Hadoop. So I will give high level overview of Hadoop, and then we will start GCP. Okay, but today's session is completely introducing the cloud computing to you, GCP to you. But before that, I will introduce the evolution process, how actually the data engineering got evolved, and after that we will see GCP cloud. Okay, so I want you to understand our previous things that we have discussed. I want you to recap. So we do data engineering for business, right? And business growth and decision making. We know this, right? We have discussed this in our last sessions. So we'll be having application layer, and we'll be having data warehouse layer or OLTP layer. Sorry, data base layer or OLTP layer. And on top of that, as a data engineer, we will be doing ETL process, extract, transform, load process. And then we will load transformed data into a data warehouse platform, which is actually the OLAP. Okay. And on top of that, business will do the business intelligence process. And out of business intelligence process, decision making, business growth, and business value will be the outcomes. Okay, so this things will be there in any kind of a business. You take retail business, you take healthcare business, you take any kind of a business. From the OLTPs to OLAP systems, there will be a process called ETL. Okay, extract, transform, load. Okay. So now I mentioned few technologies also here: Teradata, Oracle, SAP HANA. So these are the traditional technologies wherein people will be using them as their data warehouse systems. But later on, the data analytics got matured, and we got predictive analytics and prescriptive analytics. So that's where we are moving towards our new global data lake systems. So these systems are pretty much capable to store and process huge amounts of data. So here we follow a process called ELT, extract, load, transform. So this process will be done by data engineers only. So this is the only process that we follow. Even in cloud also, we are following the same process: extract, load, and then transform. Okay. So now we'll be having different source systems. Okay. So we'll be having OLAP data sources. we'll be having OLTP data sources, and we'll be having flat files. Sometimes we'll be having streaming applications, right? So what we need to do, we need to load our entire data from multiple different source systems to the central data lake system. Be very, very clear. This is the first and foremost responsibility. Ingestion, data ingestion process is the first and foremost step in data engineering. Be very, very clear. Okay. So your data should be transferred from your source system to your target system. Okay. Whether you process and then transfer, or whether you load it into raw and then process, it's your architect decision. Be very, very clear. If the raw data is needed for the business, then definitely they will load data first and then transform. But if there is no need of raw data, if they need only processed data, then we need to build pipeline in such a way that we have to follow extract, transform, and then load. Okay. But in today's world, people are expecting raw data to be in the cloud platforms. Okay, because the storage is very cheap in the cloud. Okay, so they are making global data lake systems in the cloud. Okay, so now for the futuristic purpose, they are maintaining at least 2 to 5 years of data in the raw zone. Okay, so we ingest the data. Okay, so what is the next step? We need to process it. Okay, we need to process it. So how we will do the processing? We will be using a lot of technologies in the data engineering. So one of the technology is Hadoop and Spark. So these are the two technologies that we used to use in on-premise systems. Okay, so in cloud we'll be having different services. We'll see them later. But before to Hadoop and Spark, right? Before Hadoop and Spark, what are all different technologies we'll be having? We'll be having data stage, Informatica, right? AB Initio. So these are all the technologies which will be serving the ETL kind of purpose, right? So the traditional systems are gone, and Hadoop came into the picture to solve all our big data problems. So why Hadoop came into the picture? Hadoop is the most advanced data engineering framework. Hadoop, Spark, Kafka. So these tech stack, we call it as big data tech stack, right? So these technologies will be using to prepare the central global data lake system. Okay, in on-premise systems, Hadoop, Kafka, Cassandra, Spark, HBase, Hive. So these tech stack is big data tech stack. So to solve all the big data problems, so traditional data warehouse systems are good for somehow. So, but if people want to implement data science and machine learning kind of environments, then we need a strong data platform to support all these advanced analytics, right? So traditional systems are good to up to some extent, like in Oracle, Teradata, and SAP HANA. So these are all data warehouse systems, and they are serving business intelligence purpose, and then uh, they are good up to some extent. But our analytics are becoming matured, right? So people, I mean, in today's world, so analytics are becoming matured in such a way that, so we need to implement predictive analytics, we need to implement prescriptive analytics. So these analytics needs a lot of data in the data platform, and a lot of processing speed needs to be there. So which our traditional data warehouse systems are not capable enough. So that's where Hadoop come into the picture, and Hadoop solved all these, large data and large data processing problems. Okay, so that's how the evolution happened. And now, for some time, up to 10 years, Hadoop era was there. And even I started my career in big data engineering. wherein I used to work in Hadoop and Kafka, Java, Spark, all these technologies. I used to work in early 2016-17. But today's world is completely cloud, right? So there are few. I cannot say Hadoop was completely dead, okay, but the percentage of usage is completely reduced, right? So I would say there are few bank systems, or there are few bank clients who are still using Hadoop platforms, okay, but most of the clients or most of the users are completely moved towards cloud, okay. So I'll explain the reasons also. So when we are talking about Hadoop and Spark systems, if we want to maintain them in the on-prem, the cost will be very huge. So the reason is they runs in a cluster environment. Okay. So now let us understand a bit more deeper how these Hadoop and Spark are solving the big data problems. Why Teradata and Oracle, they are not capable enough to process this much data, to store this much data, right? But why Hadoop is why Hadoop is picked in that case, right? So your Oracle or your Teradata or your SAP HANA data warehouse systems are capable enough to store certain volumes of data, to store certain types of data, to store, to process data in certain speeds only. So they are limited. They can store limited volume of data. They can store, they can process data in limited speeds only. Okay, if you give, if you store 1 terabyte data in Oracle table, and if you try to execute a query on top of 1 terabyte data, then your database data warehouse, even your data warehouse also will be dead. Okay. So now what is the comparison traditional versus Hadoop? Because this Hadoop architecture is very, very important to the to go into the cloud systems. The reason is the distributed computing and processing process, or the distributed storage. These two concepts got introduced by Hadoop framework, and the same concepts will be utilized in the cloud as well. Okay, so let us understand a bit deeper into the distributed storage and the distributed processing. Okay, so I just want to introduce, Hadoop architecture to you so that you can understand what is distributed computing and distributed storage. Then we will move on to cloud, followed by, but I just want you to understand how these, cloud systems are working, right? So once this Hadoop got evolved, and it introduced distributed storage, distributed processing, then these cloud systems, I can say they purely copied the architecture, and then they implemented the cloud services, right? So that's where the magic happened, and then end of the day Hadoop was dead because of its on-prem costly nature. High maintenance needs to be there for Hadoop. So that is where it has its own complexities. Though it is a solid technology, it has its own complexities in terms of infrastructure maintenance. Okay, so that is where people are moving towards cloud systems. Okay, so now let us understand what is the difference, how Hadoop is solving all these problems. Why not Oracle or Teradata? Why not some other database uh, is not able to handle this much volumes of data, is not able to process this much volumes of data? Let us get into a simple glance of Hadoop architecture. Then we will try to move on to GCP introduction. Okay, so I have few slides for it. Okay, so before entering to Hadoop, so I will try to explain how our traditional data warehouse systems will work. Okay, So initially, when we take any kind of a data warehouse, okay, any kind of a data warehouse, right? So data warehouse. So let us take an example, your Oracle, okay, or Teradata. We'll take Teradata. Okay, this Teradata database management system or OLAP system, whatever it is. So this softwares. So this what is this Teradata? It's a kind of a software package, or even SQL Server is a software package. Similarly, Oracle is a software package. So what we need to do, we need to install that package in a server, right? In a machine, we need to install that package. Correct. So now I have a server. Okay. Now let us assume this is my server. Okay, and my server have 1 terabyte storage and 128 GB RAM. Okay, so this is my server configuration. Now I installed my Teradata on top of this server. Okay, so now once my ETL jobs are running, the data is continuously loading. So periodically, my ETL jobs are loading the data into this Teradata data warehouse. Okay. Now, this on top of the Teradata, there is a business intelligence layer, because after data warehouse, so there is a BI layer, right? So which where actually we visualize the data in the reporting tools. So some of the reporting tools like Power BI and Cognos, Oracle OBI, even Oracle Business Intelligence. So these are some business intelligence tools. Okay. So once data engineer on a platform in data warehouse or data lake, it may be, this data analyst or data scientist will connect to the data that we placed, and they will run the business intelligence on top of our data. So that business intelligence they'll do in some kind of a tools, like visualization tools. So they will take the data and they will present it to the business owners in terms of graphs, in terms of pie charts, whatever it is, right? Bar charts. So the charts will be prepared by these DS or DA teams. Then out of that, they will derive some business value or decision making or whatever it is, it will happen from there. So this BI should connect to the data warehouse and execute a few queries and then read the data. Okay. So now what is happening? My ETL jobs are continuously loading to Teradata, and my server capacity is 1 terabyte and 128 GB RAM. So at certain point of time, my entire server memory got filled up, right? So now what will happen? Your Teradata software will start behaving weird. I mean, it will run slowly because your memory is already occupied, right? You're periodically, incrementally dumping the data to Teradata, and your Teradata is once it reaches its peak maximum amount of data volume, it won't be able to handle, right? And remember, you can ask a question saying we can purge the data or we can delete the data in Teradata. So no, it's not possible to delete the data. So you we need the history, the complete history of the records. So that's when the business intelligence will be more accurate if we have history of the data. So what will happen? So your Teradata will start behaving, slow, or will start working slow because your complete memory is occupied. Now what will happen? The vertical scaling, right? You will scale that same server. You add memory, you add RAM, you add motherboard, or you add network,
So vertical scaling capabilities we need to implement for this server. Okay. So now what will happen? So at certain point of time, the cost will be very huge. Okay. And this BI is trying to connect to this Teradata because of this space issues. They are not able to get the data on time, right? So that's where the storage of huge volumes of data and the processing of huge volumes of data is became very very complex in the traditional data warehouse systems like Teradata and Oracle or SQL Server, it may be. Okay, so that's when they understood, or researchers understood. Uh, okay, so we are getting a problem in 2020 generation. So we need a platform to support very vast volumes of data and to support a very large data processing. So that's when they introduced Hadoop. Okay, so that's how Hadoop came into the picture, guys. So there are few problems in the traditional data warehouses. Then, after identifying those problems and the data growth that is happening in across the generation, so you understood the today's generation, right? So we are generating data like anything. So every person, uh, you just take your mobile, how actually you are using all the apps. So where it is, the data is getting generated and it is stored in some place, right? So every day Facebook generates around 4 petabytes data. The same case with WhatsApp as well. So how actually they are storing and maintaining all this data, right? So you still can find your 10 years back charts, right? In Facebook, if you open, you can find your 10 years back charts also. So they are not deleting anything, right? Until unless you delete. Okay, so how they are maintaining all this data history, right? So that's where your traditional data warehouse systems are failing to store this much volumes of data. And also the structured format is matters, right? So today we are texting and we are doing messages, we are uploading images, we are doing a lot of reels, videos, all this stuff. But your traditional data warehouse systems are meant to store, or they manufactured to store only the data in the form of tables. Okay, but if we want to store a video or a photo or images or PDFs, whatever I'm getting from the web application, I want to store it is as is. It is not possible in your RDBMS systems, because your data warehouse systems, traditional data warehouse systems like Oracle, Teradata, or SAP HANA, they are bounded with RDBMS principles, relational database management principles, right? So they can store the data in the form of tables only. Okay, so that is also one of the limitation in traditional data warehouse systems. Okay, so the generation is moving and people are playing with a lot of unstructured data. Okay, a lot of unstructured data, meaning so images, videos, PDFs, right? So people are generating a lot of unstructured data, but your data warehouse system is not capable to store unstructured data. So that is also one of the limitation researchers identified. And then they came up with this kind of data lake system, which is Hadoop, right? And these systems, traditional data warehouse systems, are single server architecture. Remember, single server architecture. So they can there will be a server, and on top of the server, we send the request to that server, and server will respond to you. Okay, the single client server architecture we'll call it as. Okay, so meaning, so this is server, to this server there will be a client. Okay, and this client will be sending the request. Okay, so this client will be sending the request, and that request will be taken by this server itself, and then this in the same server you will get the response. So that is where we actually can use the client server architecture. So when the client send the request to this database server, your database server will respond to that request. Okay, so here basically, if this server is dead, or if this server is very busy with huge volumes of data, or huge data processing, then your response also will become very slow, right? So your response will become very slow. So that's where your BI reports will be dead slow. So that's one of the key problems. And this vertical scaling, so you can ask a question, hey Venkat, we can actually increase the capacity of this server. Yes, you can increase the capacity, but till what extent, and what is the cost related things that we need to consider, right? So this is a client server architecture. Our traditional data warehouse systems are technically a client server architectures. Okay, but Hadoop is different compared to your traditional data warehouse architectures. Be very, very clear. Hadoop is different. So Hadoop is a distributed storage and a distributed processing framework. Okay, and it is a cost effective storage solution for large data volumes with no format requirements. Be very, very clear. Your Hadoop platform can support any kind of data. Okay, you dump anything, it will take. So Hadoop is schema on read platform. It is not schema on write platform. Be very, very clear. Okay. If we want to store structured data into a database, that is schema on write platform. We create a table, then we load the data. Okay, but in Hadoop you don't need to do that. You load the data, then process it, then create the tables, then read the tables. So that's how the process will be. Okay, now the traditional data warehouse systems follows client server architecture. Hadoop follows distributed storage, distributed processing architecture. So what does it actually mean, right? So let us understand. Yeah. So let us understand the distributed architecture of it. So Hadoop runs on a cluster environment. Okay. So meaning, so I'll just simplify it. You don't need to learn all this stuff. Okay. I'll simplify and I'll explain. So yeah, I will take this. See here. So this is how actually your Hadoop runs, right? So there will be a master node, and there will be multiple data nodes. Node meaning server. Okay. So master server and multiple slave servers. 1 minute. Okay, sorry. I got some messages. Okay, so there will be a master server, and there will be multiple worker machines. So that's where the distribution comes into the picture, right? So when the client send the request, your master machine will handle that request, and it will talk to your worker machines, and accordingly it will do the job. Okay, so let us take an example. You are storing a file. Okay, 1 terabyte file or 100 GB file or whatever it is. So your name node will, or name node means it's a master machine. Your master machine will take that request, and it will talk to your worker machines. Okay, it will talk to your worker machines. Hey, which worker machine have space? So then accordingly it will place the file into all the machines. Okay, so you may get confused at this moment. Let me take a new slide. I don't want to confuse you guys. Okay, we'll take our own okay diagram. Let us say master machine. Okay, so we know traditional servers will traditional data warehouse systems will follow client server architecture, where we'll be having single server, right? But Hadoop is different compared to the traditional data warehouse systems. How Hadoop is different? Hadoop follows a distributed computing or distributed storage architecture. So what does it mean? Now let us understand that part. Okay, so here I have one worker machine, worker one. Okay, I have worker two, and I have worker three. So now I have one master machine and I have three workers. Okay, so now these all machines are connected in a network, single network. Okay, single network. When we connect multiple machines in a single network, and if we form a group of machines, then we call that as a cluster. Okay, in real time we call that as a cluster. So we have a master machine, we have multiple worker machines, and if we connect all of them in a single network, we call it as a cluster. So Hadoop or Spark for that matter, or Kafka, or you take any kind of a big data technology. Okay, so they run in cluster environment. They don't run in server like environment. Okay, single server like environment. Okay, so now what happens once you install and configure your Hadoop in this cluster? Okay, I have a 4 node cluster. We call it as 4 node cluster. Node means server. Okay, now this is a 4 node cluster, and you have a master machine and you have worker machines. So now when you install and configure your Hadoop, the master process. So in Hadoop also there will be a master process and worker process. Okay, so these two processes are JVMs, simply Java services. So they'll be running in the master machine and worker machine continuously. They'll be running master process and worker process. So as and when your client send a request, okay, your client sends a request for storing a 100 GB file. Okay, now what your master machine or master process will do, master process will take this 100 GB file. Okay, and it will split it. Okay, 100 GB to 100 GB. Let us take an example. I have three worker nodes, and I have okay, so I have three worker nodes, right? So your master process, what it will do, it will talk to your three worker process, and then it will split it into chunks. Okay, so chunks, your entire file will be splitted into multiple parts. Your 100 GB will be stored in multiple worker machines. Okay, so now your data is distributed. Be very, very clear. This is what distributed storage. Your 100 GB file is not stored in a single machine. Your 100 GB file
will be splitted and stored in multiple worker nodes. Okay, then when we want to read the data, how your master machine will do? So your master machine will log it. Okay, so worker machine one have two parts of this 100 GB file. Okay, worker machine two have two parts of this 100 GB file. So your master machine will note down all the details of entire trace. Okay, so it has this log, and it will go and check in this log which file is stored in what machines. Okay, so it has its own algorithm to find out in what machines it has to store. Okay, but the chunking of the data is depending on a concept called block. Okay, so there will be a concept called block size. Okay, so depending on the block size, your data will be chunked into multiple parts, and it will be stored in multiple nodes. Okay, now if your storage space is over, right, you can go horizontal scaling, add one more worker. Okay, without disturbing the production, without having any downtime, you can simply add this machine to your cluster. Okay, so this is horizontal scaling, but your traditional data warehouse systems follows vertical scaling, which is more costly. Okay, and it involves downtime also. So it is distributed storage. So your master process will take this request, storage request, and it will chunk the data into multiple parts, and it will store in all the nodes. Okay, now what is distributed processing then? So this is important, right? So you store the data distributed way, but if I want to process the data, how I will process? Now that is where the concept of data locality. Okay, there is one more concept. These are all big data concepts, guys. I mean, I don't want to confuse you, but I just want to introduce these concepts to you because these are same in cloud as well. Okay, so data locality, meaning when you are sending a processing request, what do I mean by processing, right? So here let us take an example. I stored the 100 GB data, and I want to apply a filter. Okay, filter employee underscore name equals to Venkat. So this is my processing. Okay, I have sent a storage request. Now I am applying a processing request. Now what your master process will do, your master process will detect this, and it will detect all the partitions files that are there in the workers, and it will send this logic to the worker process. Okay, it will send, the master process will send this logic to the worker process. So your worker process will be running in all the worker machines, right? So what it will do, it won't execute this logic on the entire chunks, right? So each worker one have two partitions of the 100 GB file. So worker process will take this filter logic and apply in two partitions, apply on top of two partitions, and worker process 2 similarly it will do, and worker process 3 similarly it will do. So it is not running on the entire data as like your traditional data warehouse systems, but it is running on the parts of your data. So it is distributed processing. Okay, your logic will be sent to your data. Okay, but in traditional data warehouse systems, your data and logic stays in the same server. Okay, your data will be transferred in the traditional data warehouse systems, but here if you see, your logic is moving towards your data. So what will happen, your worker process will take the logic and apply it on top of small partitions it has. Now at the end, all the worker processes return the data to the master process. So your master process will give the response to the client. So this is what distributed storage and distributed processing. Anybody have any questions, guys? Any queries till now to understand this distributed architecture?
Yeah, clear.
Any questions or queries? Please ask if you have any questions. Okay, so till now we are clear on how actually the distributed systems will work. So they runs in a clustered environment, and they follow distributed storage and distributed processing. We know that. So now Hadoop was there previously for us, and because of its maintenance cost, or because of its huge cost, uh, uh, huge costs to the business owners. So they are moving towards cloud environment. So the reason is Hadoop runs in a cluster environment, and that cluster on premise they have to maintain, because in my career I have seen around 3,000 node Hadoop cluster also. So for a client called American Express, so they are maintaining around 3,000 to 5,000 node Hadoop cluster for storing their data for analytics purpose. So that's how in real world they will implement. So on a large scale, so the on-premise systems are they are complex in maintenance, and cost occurrence will be very high. So that is the reason people are moving towards the cloud platforms, right? So that's where the market for Hadoop also came down, and people are looking for cloud data engineers, not the uh, actual data engineers who worked on the on-prem, but they need cloud data engineers now. So the project requirements also coming like that. So it is good to understand about big data technologies, and but the ultimate goal should be to learn uh, cloud data engineering. Okay, so but the concepts remain same. So whatever we do in on-prem data engineering, the same things we'll do in cloud as well. Okay, so the cloud computing has also its own advantages, right? So yesterday we have discussed, in our last session we have discussed, so it has its own features or advantages, where that features we won't get in on-prem, right? So these all things made us drive towards cloud computing. Okay, so before our on-premise systems we used to work with, the data engineers, we used to work with these advanced tech stack, like Hadoop, Spark, Kafka, all these tech stack. But now the data engineering along with data analytics got matured. So I mean, we are moving towards the cloud computing, because of this costs related issues and maintenance related issues with Hadoop platforms. So we moved to cloud data engineering. So going forward, all the data engineering world will be in the cloud. Be very, very clear, because we are in AI world, right? So AI is something that is changing the world now, right? So that is also uh, the systems they are depending also in the cloud, right? So we have AI everywhere. So they integrated this chart GPT or everything with the cloud. So now everything is in cloud. So that is where I started this batch for Google Cloud. So going forward, we will be learning data engineering in Google Cloud platform. So this is clear. Okay. So why we are going there is what the history. Now in today's session, whatever we have discussed, so today's and yesterday's session or day before yesterday's session.
So these two sessions will answer the question why we are going for cloud data engineering. We have data engineering on-prem as well. So you can, if you can revise my today's and day before yesterday's session, you will come to know why we are going there. Okay. So definitely we will kickstart our GCP sessions from tomorrow. Today I just want to introduce the distributed process to you. Okay. So tomorrow we will start looking at Google Cloud Platform. And tomorrow's agenda is I'll just introduce the platform to you and what are all the services that we are going to concentrate as part of this course curriculum. Okay, so that things we'll discuss tomorrow. But for today, try to understand. I request you to go and explore about these distributed technologies or big data technologies. Okay, so the only technology that was still alive in cloud also is Spark. So we will see that Spark in GCP as well, and we have Spark in AWS. We have Spark in Azure as well. So unfortunately, Hadoop is no more in the cloud. So we'll be having different services. But in tomorrow's class, you will get more clarity on what services we'll be focusing on in GCP, how GCP works, for that matter, how any cloud platform works. So everything we will see in tomorrow's session. Okay. So thank you so much for joining once again tomorrow, guys.
Thank you.